Very good morning all. Today we are going to see about noise models. Okay, what is noise models? What is noise? We all know that noise is a disturbance. But in image processing, it's also a disturbance in any image during acquisition and transmission. There are two types of noise, that is image acquisition and image transmission. Okay, what is acquisition? It is of environmental conditions. That is, in image, the image is corrupted by any environmental conditions. Image transmission is as of like acquisition, it is the image is corrupted by environmental conditions. In transmission, it is corrupted by atmospheric disturbances. And the next is noise model assumption. We can assume the image is whether noised or not under these two categories, and the first one is independent of spatial coordinates and the second one is uncorrelated with the image. There is no relation between the pixel values and noise components. What does this means is independent of spatial coordinates. You will all know what is the spatial coordinates in the next slide, that I'll explain the types of noise. And the second is uncorrelated with the image, that is noise, image and the pixel values. That is, image have many pixel values and we should assume that it should not. While we are correlating, the image one is overlaid with the another. If we changed image of one, it will be like similar to the another. So if uncorrelated, it will not mix. That is what it explained. Okay, now types of noise models: Gaussian, Rayleigh, Erlang or Gamma, exponential, uniform and impulse. Impulse is nothing but salt and pepper. Gaussian noise. Okay, here explains the formula. Okay, in this diagram it explains us the two sides are curved. Like I said, the assumption independent of spatial coordinates. Here Gaussian noise is independent of spatial coordinates, and it is the most easiest way to remove noise. And the next is here Rayleigh, Erlang, Gamma and impulse. In Rayleigh, as you can see, the first coordinate, first graph is standing straight, and then the coordinates is slightly curved. And in Erlang, it started with the axis and it started to curve. In impulse, okay, from here you can see the impulse is having two straight lines. And the next is effects of noise on images and histograms. The above row has some patterns of black, gray and white. It has been histograms by the types of noises. As from the diagram of Gaussian graph, you can see that how the graph came, like the previously I have told, right? Both sides having a curve, and in Rayleigh one side is straight and another side is a curve, and in Gamma it started from the axis. And the next three examples is exponential, uniform and salt and pepper. As previously I have not explained about the exponential and uniform. Uniform is nothing but of straight rectangle graph, and exponential is straight line starting with the y-axis and then ending with an x-axis. That's it. In salt and pepper, you can't see the graph, but there is two straight lines. It's very thin, I think so. I will explain about the salt and pepper, that is impulse noise. If the image is noised or corrupted by black, then it can be correlated by white, because if the image is black, we have to remove the noise by white so that it will be brightened. If the image is... Next is applicability of various noise models. Gaussian noise is used in electronic circuit noise and sensor noise due to poor illumination, or high temperature. Rayleigh density is of characterized noise phenomena in range imaging. Exponential and gamma densities, laser imaging. Impulse noise occur when quick transients take place during imaging. Uniform density, the least descriptive of practical situation. And the conclusion, as of I said, image acquisition and transmission, noise is seen in images. This is characterized by noise model. So study of noise model is very important in image processing. Thank you.